Prabhashri, Assistant Professor, Department of Mathematics, SNS College of Technology. So today we are going to see a case study video in a ordinate differential equation. My student will continue this.
Hello everyone, I am Kavimanya. I am going to talk about application in population biology and medicine. Predicting population growth and decline in cities and countries. Modeling birth rate and death rate variations. Spread of infectious diseases, epidemics and pandemics. SIR models for disease transmission. Growth of bacteria, fungi and microorganisms. Tumor growth and cancer modeling. Drug absorption and distribution metabolism. Heartbeat and blood flow modeling, predator and prey, models in ecosystem, fisheries management and wildlife conservation, agriculture, pest control and crop protection, genetic regulations and gene expression models, neuron activity and brain signal transmissions, population competition between species, modeling vaccination effect in populations. Thank you.
I am Nikashvi. Applications in heat transfer and thermal engineering. Cooling of hot objects using Newton's law of cooling. Heating process in oven, boilers and furnace. Design and working of refrigerators and air conditioners. Thermal management in electronic devices. Heat dissipation in CPUs and power systems. Heat exchangers in industries. Temperature control in chemical process. Installation design for buildings, solar heating and energy systems, temperature variation in atmosphere and weather systems, thermal analysis of engines, turbines and power plants, food preservation, freezing and storage systems, fire safety and heat spread modeling.
I am Muthu Sahana. I am going to talk about applications in electrical, electronics and communication, analysis of RC, RL and RLC circuits, charging of capacitors, current and voltage variation over time, design of analog filters, low pass, high pass, band pass, signal processing in communication systems, noise reduction and signal enhancement, power system stability and load analysis, modeling of transformers, motors and generators, oscillators and waveform generation circuits, control systems in automation and robotics, embedded systems and microcontroller based devices, feedback systems in amplifiers, wireless communication systems, digital signal processing, antenna and electromagnetic wave modeling.
Hi everyone, I am Kritika. I am going to tell about applications in mechanical, civil and physical systems, motions of objects using Newton's laws of motion, free fall and projectile motion, rocket propulsion and satellite motion, vehicle dynamics, suspension systems in automobiles, vibration analysis in machines and structures, spring mass damper systems, structural analysis of bridges, buildings and towers, fluid flow in pipes, canals and rivers, aerodynamics of aircraft and automobiles, parachute and skydiving motion, rotational dynamics of mechanical systems, earthquake, earthquake vibration analysis in buildings, wind load analysis on structures, robotic motions and kinematics.
Hello.
In this, I am going to explain the application of complex integration in a simple way. So first, complex integration is useful in evaluating difficult real integrals. So some integrals are very complicated in a real life calculus. And then some integrals that are very complicated in real calculus can be solved easily using a counter integration method. Second, we use the residue theorem, which helps in calculating integrals around singular points. That is, the residue of the equation integral over c f of z into dz, which is equal to 2 pi I into residues, summation of the whole residues. This theorem helps to reduce the complex problems into a simple calculation by finding residues. So the third, complex integration is widely used in engineering applications, in signal processing, It helps analyzing signals and systems. In control system, it used to study system stability. In electromagnetic theory, it helps solving fields equations, and in fluid dynamics, it is used to model fluid flow. Finally, it also useful in solving differential equation is very much common in science and engineering problems. So overall, complex integration is a powerful tool that simplifies calculation and how wide real world applications, and has a wide real applications also. Thank you.
Everyone, I am Monica. I am going to talk about applications in chemical, environmental, and industrial engineering. Chemical reaction rate equation, batch and continuous reactor design, mixing and separation process, diffusion of gases and liquid, pollution spreading air, water pollution and wastewater treatment, climate change and global warming models, ocean current and environmental flow system, oil and gas reservoir simulation, industrial process control and optimization, waste management,